Now let us see how to check whether a given function is one or many one type. Now a simple procedure for that is that first we assume that the function is many to one. That means we can have f of a equal to f of b, where a and b are two different quantities, right? Now on simplifying this particular equation, that is f of a equal to f of b, if we get a equal to b, only then we say that the function is 1. Otherwise the function is many to one. So what it means is basically, if we recollect the definition of 1 and many one, when a function is many to one, we have two different elements in the first set which map to the same value in the second set. So in this case we call this as many to one function. So what do we assume in the beginning is that the function is many to one, that is a and b are two different values. But on solving and simplifying, if we get that a is equal to b, right, it just means that a and b are not two different values but one and the same values. So in that case this a and b is nothing but a single value, so that many to one relationship will be nothing but 1 to 1 relationship only. So therefore to prove the 1 to 1 nature, we follow a method of kind of contradiction, that is our original assumption of a not equal to b is contradicted by the conclusion that a is equal to b, right? Now if we are not able to prove decidedly that a is equal to b, then it just means the other way, that is the function must be a many to one function. Alright, so that is the procedure to check the nature of the function. Just as a note, we have to remember one terminology, that is a 1 function is also called as an injective function. Okay, so that is one terminology. Let us solve few questions based on identifying whether a function is 1 or many one, right? So here we are given the expression of the function as f of x equal to x cube. Now one more important consideration, that whenever we are not given any information about the domain and the codomain of the function, we have to assume them as the set of real numbers. So here also, since nothing is mentioned and we know that the cubic function or a polynomial function is continuous over entire real domain, so we assume here that we are talking about real numbers. Now to prove or to find out whether it is 1 or many one, we first assume, as we have seen previously, that we have to assume that, say, f of a equal to f of b, where a is not equal to b, right? Now if f of a equal to f of b, then we can definitely write a cube is equal to b cube, right? So on simplifying further, we can have a cube minus b cube is equal to 0, and hence on factorizing the left hand side, we have the factorization as a minus b into a square plus ab plus b square is equal to 0, right? Now here one conclusion is that a minus b is equal to 0, or the other conclusion is that a square minus ab plus b square is equal to 0. Sorry, a square plus ab plus b square equal to 0. Now we know that if a minus b is equal to 0, it means that a is equal to b, right? And that is the condition we want for 1 to 1 nature. But for that we must prove that the second condition is not valid. That means if we are able to prove that the second condition is not valid, then the only remaining condition is a equal to b, which will decidedly prove that the function is 1. So how do we prove, or how do we know whether the second condition is valid or not? That is, if a and b are two real numbers, then can we have a square plus ab plus b square equal to 0, right? Can we have it? So that is what we have to check now. Now if we consider a square plus ab plus b square. What we can do is, let us consider the first portion as if it were a quadratic in a, right? So therefore here we can write that as a square plus ab plus, now to complete the square, what we will have to add is b square upon 4, right? That will give us the constant term in the completed square, plus b square as it is, and we must subtract the b square by 4 which we added on our own. So now this gives us a plus b by 2 the whole square, right? Plus here we get 3b square upon 4, right? So now here we have to see whether can we get this as equal to 0. Now we know that this 3 by 4 is a positive number, so we are left with two square quantities. Now we know that this particular quantity has to be definitely greater than or equal to 0, and the second quantity is also greater than or equal to 0. Now if second quantity is 0, it means that b is equal to 0, and here if b is equal to 0, then we must have a also equal to 0, therefore we will have a square equal to 0. So therefore, it boils down to the fact that ultimately a is equal to b, and which is nothing but 0, that's the common value of them. But then what it means that a is equal to b, which is same as the first possibility that we have seen initially. So therefore what it means is, from the particular condition given, the starting point, we always prove that a has to be equal to b for the given particular expression. So therefore the function is 1 1 function, right? Now another way of checking whether the function is 1 1 or not, if we know the graph of the function, is that let us draw the graph of the function, and then we can see how pictorially we can find out whether the function is 1 1 or not. If you see the graph of cubic function, on the positive side it will go on increasing like this, and on the negative side it will go on decreasing like this, right? Now if the function is 1 1, it means that for a specific value of x, for only one value of x, we will get a particular value of y, that is nothing but the function. Or in other words, there are no two values of x for which we get the same value of the function f of x. And it's clear from this particular graph that if we draw any horizontal line, that is a line which is parallel to x-axis, wherever it cuts the graph, it will have only one value of x there. Alright. So in other words, a horizontal line will always cut a graph in a single point. So that proves that the function is a 1 1 function. Now let's go ahead and solve another question. Now here also we have to check whether the following function is 1 1 or many 1. Now here we start off with the assumption that let f of a be equal to f of b, where a is not equal to b. So therefore we have a square plus a is equal to b square plus b. Now bringing all terms on left hand side, we can have a square minus b square plus a minus b equal to 0. Right? I am purposefully clubbing in this way so that we can factorize now. A square minus b square is a plus b into a minus b, and the second expression is as it is, that is a minus b. So we can see that a minus b can be taken common, and what remains in the second bracket is a plus b plus 1 is equal to 0. Now this implies that either the first factor is 0 or the second factor is 0, right? So this means that either a equal to b or you have a plus b equal to minus 1. So it means that it is not always true that a is equal to b, but there is another possibility also that a plus b could be equal to minus 1, which still makes f of a equal to f of b. So therefore we are not decidedly getting a equal to b as the only conclusion from the given starting point. Hence the function is not a 1-1 function, but it is a many to one function. So that's how we find out whether the function is 1-1 or many-1.